Alrighty, hello everybody, welcome back. Okay, I need that wire to not be scraping the floor because that's not gonna sound too good. Alright, so Child of Ether. What are we doing? Child of Ether. Combat. I want to try a different approach to combat. Now, the card system stays, but it's the way we attack the enemies that I wanna try dealing with. So we're gonna position our player next to an area that has some enemies in it. We also need to sort out some sky related issues. Cool. There we go. All right. So we got character here. Yep. And we're gonna place that right there. Place this right here. Cool. And then take the player. Let's port them here. And beautiful. So this is going to be kind of a wild idea, but for the combat, I'm going to try Typing of the Dead, which is where we have characters. When we approach to these characters that we attack, right now you can see that, well, we crash right now. That's what we see. Let me just quickly resolve that so we can actually work with it. Knives is a function removed from base array. Really? It's probably remove index, isn't it? I'm hearing noises. Ah, yeah, that's the game. Okay. Remove at is the proper term. Any other uses? Oh, plenty. Except we already updated the remove at in those locations. Okay, cool. Right, so right now we have a dot, and then we click on it, and then the game just kind of uses the first available card. So for some reason my up movement isn't actually up movement right now. We'll have to figure that out. Okay, so we get close to this, and then we do this. Which, you know, it's the first thing that I did, and it doesn't really work that great. So what I'm thinking is, could we do something like, something along the lines of, there's going to be a word that appears, and we have to type in that word on the keyboard in order to deal damage with the top card available here. That's what I'm thinking. Now, in order for us to do this, we have to think about how this combat system is going to be organized and how it's going to play out. Yo, sup. Sup yourself. Soup is up. So if we are standing next to like 3 enemies, and they all pick the same... Well, okay, they cannot pick the same word, we can guarantee that. But what if they pick the words that start with the same letter? In that case, when you start typing in the first letter, you're going to end up filling out the word for multiple enemies. So we have to guarantee that multiple enemies don't use the words starting with the same letter. The first letter will determine which enemy you're targeting. Okay? That's what we're going to do. Got another question. How to make mesh stretch from one node to another node. I think the Godot subreddit is going to be your best choice for those kinds of questions because, you know, trying to work on a project here. but usually scaling is what you want to do. And scaling isn't done in pixels. Scaling is a scalar value, so you have to take position of the first node, position of the second node, calculate the distance between them, and then convert the scale value from 0 to 1 to 0 to whatever that value that you've just calculated, the distance value. Your mesh must have a distance of its own. So that's what I would do. If it's a simple mesh, like a line, for example, then it's fairly straightforward. Okay, so we pick the 3 enemies. If we're standing within the proximity of the 3 enemies, then their words are going to appear. We want to make sure that movement keys like WASD don't count as attacks. So maybe some sort of a modifier key would be required. Let's say maybe we'll press a button that indicates we're now in combat mode. So when you start typing, that begins the attack. Okay, well, if we're gonna commit some time to this, I guess we'll find out how that is done, and if it doesn't work, then it doesn't work. Maybe at least we've given it a try. So what's the first thing we need to do? First thing we need to do is we need to get ourselves a dictionary. We need words. So make a data folder, and what do? So array of clean words. Array of English words. GitHub. Okay. Now the problem is that it's going to have all words, including curse words, which I don't really want. Similar Spanish words, French words. I think maybe somebody had mentioned word approximate, not there. Filter set of bad words out of PHP array. Okay. Google 10,000 English words, no swears. What's this? Okay. The single letter words. Oh. Remove more. Oh, that's a commit message. Okay. Let's take a look here. Repo contains a list of 10,000 words, most common English words in order of frequency, as determined by n-gram frequency analysis of Google's trillion word corpus. Swear-free list. There's an additional list which is identical to the original 10,000 words, but this with the swear words removed. Swear words are removed based on these lists. 2 additional lists with identical. Okay, so we don't want to do training, but let's take a look at what we got. English. Remove. All right, well, let's download it. I'm gonna download it right here. What do we got? No swears, long, medium, short. Short has words up to 4 letters. Okay. Well, that's actually kind of useful. So what are we going to do with this information? Oh, it looks like we have a single file here with the words already combined. So this is everything. The way our program is going to work, the way our game is going to work, is it's going to choose an average word or a random word, and it is going to request the player to type it in. Now, to make sure that if you're near multiple enemies, they don't all end up picking the same word or picking the word that starts with the same letter, we need to organize these things in an alphabetical order, maybe even in an alphabetical data structure. So we will pre-organize these things so our game doesn't have to do as much data processing. So for example, all words starting with the letter A will be under a key of A. Starting with the letter B, under the key of B. And maybe we'll also pre-organize them into length. Should we organize them into length ranges, like 3 words or one? I think we can avoid any word that is smaller than 4 letters. So no 3-letter words. 4-letter words minimum. And then we can organize it. We could organize it granularly. So 4 letters, 5 letters, 6 letters, 7 letters, etc., etc., etc. And then the game is going to decide which one it's going to choose. Okay, cool. What do we do? How do we go about doing this? Well, we're going to use Python in order to list through all the words and then prepare a dictionary of everything filtered out and sorted out already for us. We have Python 3.12. Cool. Okay, data, words database. Pop that in there. Don't need this. Try again. There we go. Okay, this is gonna be what is it? Organizer .py. Okay, so first things first, we need to get this text file. This one, no swears, please, thank you. Okay. Open. There we go, and we know that this is located inside of these 2 folders. Ah, okay, we have word wrap. We don't want that. And then we wanna open it with the intention of reading the file. And then, so this is source text. And then prep dictionary.json is going to be the file that we open for the sake of reading. Okay. Okay. Cool. We can CMD into this folder. then run this file. Oh, you're already there. Come on. Ah, there we go. Name R is not defined. It's looking for... Actually, this one's for writing. Okay. Invalid escape sequence. Right. If we want to read the file, I think we need to mention what? Open name mode UTF-8T. I think that's what we need to do. Let me look this up. No mention. Okay. Oh, come on. There we go. Encoding UTF-8. That's what we need. And that's the last parameter. Okay, invalid escape sequence. Does it want string? Invalid escape sequence. G. Okay. Okay, well, you make no sense. Open file. Maybe the file's too large? Nah. Okay, words database. So first we go here, master. Then we go another master. Then get access to this text file. We are opening it up with the purpose of reading it. Encoding UTF-8. That is weird. Hmm. Wait, hold on. Backward slashes, the forward slashes. Invalid escape sequence. Right. Where am I using a backward slash? Oh, when you copy paste the path from Windows folder Explorer. There you go. So that opens up the file. Fine. All right. So let's do source text. So let's line in. Looks like we could probably do this with source file, source text as line, print line. Huh. Interesting. and then we have to read a line from it. And there we go. So it gives us every single word. All right. Cool. So what do we do here? Well, we're opening up this file called prepped.json, which is right here. It is empty right now. We need to make sure that by the end, we close it. Closing part's kind of important. Okay. First things first. We need to organize the words by letter. And we need to do this using a dictionary. So var organized words. Excuse me. No var. This is Python. It's what happens when you let your brain run on autopilot. Okay, so this should be a dictionary. Is it? It is. It's not complaining about it. Okay. So let's do word key. Word primary key. We're going to take the word, we're going to get the first letter from it, and then we are going to organize this word into this first letter. After this is done, we need to write. Is it just right or right line? You can do either. We need to take this, we need to convert it into something that we can write. Problem is that we can only write strings. So we need to convert it into JSON. So JSON dot stringify encode. Oh, JSON has no attribute encode. Did you mean encoder? No, I did not mean encoder. Okay, so different programming languages has different words for it. Wait, can I? No, can't inspect. Okay. Python, JSON, library, encoder, decoder, JSON dump. Okay. Well, compact encoding, dumps. Yeah, that seems like it. Okay, so JSON dumps, organized words. Okay, so now when we open this, you can see that we have, whoa, letter T. Okay, sure. It doesn't really matter that it's not in the alphabetical order. It wouldn't really take much to make it be in alphabetical order. Let's see. Read line. Okay, so what we get in response is organized words, but it's organized out of order. So reorganize word dict into order. So we're going to make a temp dictionary. Okay, we're going to do 4x in or for letter in A, B, C, D, E, F, G, H, I. Can we just request, hold on, keys. Python dict keys. So just keys is going to give us only the keys from here. So we do dot keys. Actually, we need to make sure this is done after the loop, the with loop. Okay. So we take all the keys, then we need to sort. Now the sort work alphabetically, ascending, descending order. Integers, floating point numbers, strings, another Python. Okay. So return value does not return anything. So we just call it on this and we're done. I'm going to print keys just to verify. Dict keys object has no attribute sort. Interesting. Returns view object. Contains keys of the dictionary as a list. So it's interesting. It's a list, but you can't call array functions on it. Oh. Sort. Right. Okay. Let me double check this. Dict keys T. It only contains the letter T. Fascinating. Hmm. No, that's a little weird. It's not actually organizing it. Word. Oh, maybe it read it as one single line. Huh. Okay. Let's do this. Let's do I equals 0. We're gonna do I plus equals 1. And then here we're gonna do print loop ran I times. One time. So it's not actually looping through anything. And it could mean that it's because I'm trying to open it into a file. Huh. It does have carriage returns. So this should be reading through multiple files. Okay, let me try this. I'm gonna put this in here with this still one time. Interesting. Okay, let's take a look. Mode read. file mode, and then we bypass everything here, and then we used encoding. Huh. Writing a line using read lines. Or line in lines. Lines has to be done separately. Otherwise it just opens it up as a single string. This subject does not support context manager protocol, line 9. Which means, oh, it's complaining about this. Context manager protocol. Ah, right, with cannot be used here. So we do for line in source text as in source text. Okay, and now there's no read command to be used. We could just use word right away. Hey, there we go. So now we're actually reading one line at a time. It gave us keys. And it says dict keys. Okay, so can I bypass the fluff? Do I have to do this? No. Okay, so what gives? Can I, whoops. When I print it, can I print 0? I cannot. Can I do this? Class type. Dict keys. Dict keys, okay. So that's the data type. Python dict keys to array. How do we return dictionary keys as a list? List. This will convert dict keys object to a list. That's what we want. It would be useful if we place the correct number of parentheses. There we go. There's our list. Okay, cool. So I'm gonna do this. List. Yep, and then sort. So we're gonna sort this sucker right away. None. Okay. Oh yeah, that's right. This doesn't return anything. So we gotta do keys dot sort. Hey, there we go. Now again, not really necessary. This is just for me. But now what we can do is we can loop for letter in keys. And then we can use organized words. We will access the letter and we'll store it into the temporary dictionary under the same letter. And then once this is done, we're going to say that organized words is the temp dictionary. Cool. So we do this. Nice. Okay, now we have new line characters. We'll want to strip those out. Let's see. Trim, I think that's what we need to do. That's not what I need. Word trim. Is that gonna work? No. Python trim string trim. Ah, strip. Okay. So strip will remove empty white spaces, or it should have. Remove white spaces and characters from beginning and end of a string. L strip, R strip, or just strip. Okay. Well, maybe we can... Oh, you know what? Yeah, we're supposed to do it here. Hey, okay. Now, why is it only doing it once? Dang it! I keep opening up the wrong application. Maybe we can do it. Huh. Oh, okay. Right. So here's the problem. Here, we assign the word to it, and every next word that it reads that falls under the same word, it just overwrites this one. This has to be containing an array. So if whatever's in here is array, that might not be actually how you do it. Python if is array. How do we know if something is an array? Type tuple or list. Interesting. So I'd probably go with this. So if okay, if type of the data that is in, but there is no data. Technically, if we're doing it for the first time, there wouldn't be anything. Okay, so this is how we can do it. Make sure a key with an array exists. Okay, it's getting late. So we do if this is in, and then we're gonna get the keys, and then we're gonna convert this to a list of keys, so it gives us an array. If this key does not exist, if not this key, which is just one single first letter, is found in the array of keys, then we're going to declare it to contain an empty array. And then every single other time, after it's been at least recorded once, it will already have that array, so we should be good. And now we can guarantee that as of this point, we can append the word into the array. Okay, we don't need this because this we already verified that it runs more than once. Run it. There we go. And beautiful. So now we have all the words starting with the letter A. We do need to strip to make sure that we only have the words and not the empty spaces. There we go. So now we just got the words. Fantastic. There's L. Okay, so next we need to make sure that we get rid of any word that is less than 4 characters length. So skip words less than 4 characters. If word length is less than 4, continue. So skip that word. Len, no attribute of word. Okay, so I think in that case it's a method. Okay. And no, we still have that. Okay. Python string size. Length. Yeah, len parentheses. Oh, this is before we stripped, right? We need to strip the word again because we only do it here. There we go. Okay, so we saw some words. There's ask right there. Now, beautiful. So 4 letters. Nothing else here is going to be less than 4 letters long. Okay. All right. Cool. That works. What do we need to do next? Next, we need to organize these by length. Maybe we can just do it in this sequence here. And specifically, we want to organize them into key value pairs that represent a particular length. So we'll have, just like we have a key called A, containing every single word starts with letter A, we want to have a sub-key of 4, then 5, then 6, then 7, etc., etc. Okay, so 4, right. This is where we create the empty array. So maybe in this case, this should be a dictionary, in which case, let's do word length. We're going to get the length of the word. Okay. I think we can just do this, can't we? Ah, right. We have to do the same thing as we did here. Make sure that a key corresponding to this word length exists. So once again, we actually need to access the word primary key access all the keys inside, convert it to a list, and check if the length is found in that list. If not found in that list, then we declare it to have an array. So this is where we would have an array. And then we would append that word into that number. Okay. All right. Reload it. Yes. There's 5. Nice. I think I should have JSON viewer, format JSON, so we can easily see this. Oh, wow. Oof. Well, one thing we can be sure is that if for whatever reason, let's say we find a word that only has one word like that in that length, 11 letters. We don't have to worry about 2 enemies picking the same word because, well, they're not supposed to pick the same word and they're not supposed to pick the same letter in the first place. Like that. If we pick Zimbabwe, it wouldn't be picked again by another enemy. Cool. Yugoslavia. That's the only word. Got it. Got it. Okay. Yorkshire. Yamaha. Oh, now we got brand names. Oh boy. Oh man, really? No, come on. That's not a word. It's a brand name. It's not a freaking word. Xerox? Ah, shit. I didn't anticipate brand names to be so populated here. God damn it. What else we got? It's Wednesday, my dudes. We need to strip out brands. The problem is some brands might just be using actual words. Okay. Showers. Skilled, succeed, signal. Okay. Now, the list does say that it removed cursed words. But some words are not necessarily curse words, but they are also not exactly appropriate in the context of the game. Problem is there's just too many words to cycle through. Looking for anything vulgar. Oh man. There's gonna be a problem for sure. There's gonna be some word that'll pop up that'll be like, yo man, cancel this motherfucker. Okay, that's fine. Cool. So that is it. We have it. JSON's done. I'm actually gonna regenerate it again so that it turns it like this. 98 kilobytes. which is better than... How big is this? 74 kilobytes. Okay, I think I saw a 4 megabyte file somewhere. Cool. We got the JSON. Prepped dict. We're going to move it. Engine. I guess this is going to be data. And there we go. Cool. All right. So that means here we will need to actually open that file, read it, and make the enemies, well, display it. I think we're going to create a separate object. Okay, I will restart the recording. And there we go. Okay, so we have our dictionary file. Now, I don't want to hard code this into the enemy, because I know that there's always a chance we might not actually use this system. Let's go ahead and make this into a separate object. Okay, so this is keyboard attack node. Keyboard attack node. Okay. We're going to add an area to D, which is a little awkward, but usually we handle everything on the side of interactables or enemy detection from the player. But I feel like this time we might have to do it here. Okay. So let's increase it. So this is the proximity of detection. Kuwu board. Beautiful. Maybe I need to learn how to type first. Let's go to objects, mechanics, keyboard attack node. All right, now this has two components to it. We need a canvas layer, which is for the location of the UI, which is going to have a rich text label. Okay, we're going to give this rich text label a simple style. Actually, yeah, both of them will have the same. BB code enabled. Center. Is that it? Yes. Yeah, so it's the word center that we have to use. Okay. And we're going to go into the enemy. Open it up. Nope. It's a friendly looking enemy. Take this. Ah, right. Open the scene, and then instance keyboard attack node here. So that will guarantee that all the enemies of this type will have this node inside. Okay. Well, we see the test. That's good. Now we need to make that appear. We need to make it appear over the enemy. So we need to attach a script. Scripts, mechanics, keyboard attack node. And we need to position that rich text label in the place where the enemies are on the screen. Okay. Oh no. Damn it. We have insufficient space. How did that happen? I had more than enough. Oh, the 7-hour recording session. Dang it. Okay. Well, that's a bit of a problem. Okay. I know that the MKV is still recording, so I'm just going to grab the video from the MKV and continue working with that. Okay, good thing that popped up and I saw that. My second computer that's recording the process basically told me that I'm out of hard drive space. I guess it's time for another video blog update. Oh boy. But anyways, that's fine. Still have the MKV running. That is okay. It's going to be a separate video, but that's fine. Okay. Right. What do we do here? What do we do? What do we do? We need to make the label appear on the screen in the same place where it shows up. Where it shows up in the game. To do that, we need to get active camera. And I think there is a camera related function. Get cameras. Camera, get camera, transform, get camera feed ID. That's for physical cameras. Get camera 2D, get camera 3D. I think that's it. So we need to talk to the viewport and then get camera 3D. That's going to give us the current camera. Current cam. Okay. From there, the camera unproject position. So we tell the camera that take global position of this node and unproject it, which returns the screen position. So that is, where's this object located on the screen in 2D space? And then we'll take rich text label and then set the position to be in the screen position. Yeah, look at that. Oh wow. Some pretty far enemies. Okay, well, there you go. What else do we need? I think we need to subtract vector 2. Let's call it word. Word size x divided by 2. Okay, doesn't like it. Vector 2. Right. 0. Alright, so the word is centered now. It's really, really wide, though. Bit content. Not that way. Come on. Hey, there we go. That's what I need. I needed to expand it that way. That's good. So that's word wrap off. And then we're also going to do a little bit of contents margin. Left, right, top 3, bottom 3. Okay. Corner radius. 5, 5, 5, 5. Okay. That's the word. Maybe the top of it could be shrunk a little bit. And then for the color, make it somewhat transparent. Mm-hmm. Okay. And that looks pretty good. What's next? Next, we need to make it so that I guess we don't need to center it because it's going to be only as big as the word. But now we need to handle the dictionary, the importing of the dictionary. Okay, so word combat db. We're going to save this. Object, mechanics. Whoops. We're going to autoload, mechanics, objects, mechanics. Oh, hold on. This doesn't have to be a scene. Hold on a second. What am I doing? Close this. Don't need this. We're going to go to the scripts. And then here, global? Yeah, we could put in the global. There you go. That's perfect. Word combat db. Scripts. Nope, that's sprites. Scripts global word combat db. There we go. That's going to be added. Now we're going to actually program it. So declare variable, and then in the ready function, file access, we're going to need to open a file. We know that it's located in data. Okay. Do we need to provide any additional parameters? Actually, it's not like this. File access is the class. We open, and then it asks for the file, and the flag is we try to read it. Okay. So we have the file. Then file, read, or get, trying to run off of memory, get as text. And then we need to convert it, JSON parse string, insert the string here. That's going to convert it to a dictionary, which we can actually traverse, and that is it. That should import it. We should probably close the file. Yeah, well, okay. Not complaining about it. I might regret it, but print word db. Oh god. I saved everything. Hey, there we go. Look at that. It even protected us. It said there's too much to print. Okay, cool. Well, files are here, and the enemy code, or this damage code, does have access to it. So, how are we going to handle this? Well, first of all, we need to make sure that no two enemies use the same letter if we're working with the same enemies, or with a number of enemies in a nearby vicinity. Hmm. Hmm. We can take an alphabet, we can shuffle it, and then the enemies could use, let's say, they'll figure out what nearby enemy number they are, and they'll use that to access that letter, that shuffled letter in the alphabet. And then anytime the player is not in combat, we'll just reshuffle that array. We can reshuffle it every, let's say, 60 seconds, for as long as the player's not in the not in combat. Hmm. Keyboard attack node is what we're programming here. Word combat DB. Okay. So here's what we can do. Enemies in combat. We're going to make this into an array. And then the keyboard attack node knows, or it should know, when a player enters or leaves it. So if body is in group, okayer, nice, player group. If the body is in group called player group, then we know that it's near player. True. And then whenever the body leaves, it will be false. I'm just going to double check real quick to make sure that that is actually the group. Player underscore group, yes it is. Nice. Okay. Now, this word, we don't want it to be visible. Func ready. We're going to talk to the word, talk to modulate alpha, set it to 0.0. In the process, word modulate alpha is going to smoothly transition to either 1.0 if player near, else 0.0. It's going to transition to 0.0, and it will subtract the amount and then divide it by 5. So that's for smoothly transitioning. Okay, there we go. Now that range is mighty small. And that range is not going to be enough to do the job by itself. We're going to have to involve like a visibility check with a raycast. But that is what that is. We'll handle that when the player's actually inside of the range. There we go. Okay. Now, what's next? Well, next, it needs to acquire some kind of a word. Okay. Let me think. We could have the node pre-acquire a word based on the type of what type of enemy. Well, let's say based on the complexity, based on the type of enemy that the player's dealing with, and it could pre-acquire it in the beginning. Okay. Acquire the word. Combat word combat database. It has word database in it. This variable is for okay, so this variable is for making sure that we don't shuffle the words, the letters, if the player is not in combat. So we'll come back to that later. Right now we're interested in word DB. Within this word, there's 26 keys, one for every letter of the alphabet. We need to choose one of them. We need to make sure that if there's multiple enemies near the player, they don't all choose the same one. Okay. Suppose one enemy is inside, second enemy enters, picks the word, the player leaves, so it's no longer inside. Another enemy enters, that enemy is already the second, or that enemy is also the second, so it ends up picking the same second letter. We don't want that. We could, hypothetically, it's not a guarantee that it's not going to choose the same word twice, but we could base it off of the instance ID. Huh. That might not be a good idea. Because again, we only have 26 letters in the alphabet. So once you roll from 26 to 27, you go right back to letter A. Okay, so we have to confine it specifically to the letters that are immediately, or to the enemies that are immediately within reach. Okay, so we could hypothetically do something like this. We'll make a variable called engaged letters. So we need to make sure that when the enemy chooses a word, it chooses one that isn't a part of this, that doesn't start with letter that was already a part of this array. Okay. We can make that happen when the player enters the area. So we're going to comment that for now. When the player enters, we can do, what do we do? Var chosen letter. Chosen letter. How do we choose the letter? So word combat DB will access word database. We'll request all the keys, which are all the letters. We're going to choose a random one, rand I, based on word DB, word database, size. It's going to be based on the size, based on how many key value pairs there are. I think that is allowed, right? We can get the size. Yes, size gives us an integer. Good. So get the size, generate a random number based on that size. We get the chosen letter. Now, we need to redo this. So while true, we'll do this if the chosen letter is in we'll access the database again, and then there will be engaged letters array. Engaged letters array. Okay, if this word is in that array, it continues going. If not, that word in the array of engaged letters, we're going to append, or I guess, yeah, append. It doesn't really recognize it as an array. It's a little stupid. There we go. We're going to append, and then we're going to break out of the while loop. Cool. All right. We might want to make this variable global. Chosen letter equals empty string. We choose one of the letters. If it's not found in the engaged letters array, we add it to it and then break. That gives us the letter. And then when we leave, we need to access chosen letter and then erase, no, not erase, remove. Okay, excuse me. We're removing from the engaged letters array the letter that we've just engaged in. So that's when we leave. Now, by doing this, we return the letter back to the pool of available words. Okay. Now, we're not quite done here because we still need to choose a word. Okay. Still need to choose a word. So, access, engaged letters. Let's start with just 4. And then we are going to choose rand word. Let's do IDX. Randy. Percentage sign out of the size of however many words there are. Okay. And then chosen letter. We need a variable called chosen word. And then this is going to store the chosen word. And then we also need to put it into this text. We need to make sure that center is not required. That's right. We're growing the word, the text box based on the contents. Okay, and we have an error immediately. Why is it complaining? Invalid type string, base type array. Huh? Wait, engaged letters is not where we're supposed to be getting the data from. We're supposed to be getting the data from WordDB. There we go. Okay, we got a crash. That is okay. Invalid get index 4. Ah, word DB right. Before we can get to 4, we need to know which letter we're going to 4 in. That's chosen letter. Okay, and then I also wrote gibberish when I closed the application. Clean that up. Hey, look at that. Now, when we leave, now this is a function remove from base array. Remove. Really? It's not called remove anymore. Relist, slice, slice. Remove at. But that wants the position, not the item. Which kind of makes sense. We had remove. Erase. That's what we want. So I think I was right the first time. Erase. There we go. Okay. So anytime we leave or anytime we destroy the enemy, idle when jazz. Okay, date. Now you can see that the end of the text box gets stays as whatever size it was. So I think what we need to do is say if the modulate is less than 0.1, then size on the x-axis is going to be set to 1. So that it collapses it back to a very small size. Inch. Okay. Utah. Oh boy. Easy. AIDS. Really? Really? Come on. Oh, okay. All right. Well, where are you? AIDS. Let's not do that one. Fuck, man. This is I'm gonna pay for this, aren't I? Zimbabwe. ZNet. All right. Okay, hold on. Vagina. No. Good. It was an offensive enough word. Okay. How many TOS terms are we going to break today? All right, let's try them all. Nope, they removed that one. Oh god. I'm pretty sure they removed that one. Oh. Okay. It's not really an offensive word, but it's not a word I'd want in a game. Zinc, Zope, Zoom, Zone, Yugoslavia. Oh no, that's none of it. Okay. Hacker, Herbal, Hudson, Hebrew, Harder. Yeah, well, it's pointless. It's pointless to be looking through this right now. Because, well, let's make sure we don't forget to copy it. Copy the new one. I've set myself up for this one. It's my fault. My fault only. Copy, paste. Thank you. Just had to do that. It's probably going to be a lot more where that came from. Fans, yarn, ears. Okay. Flag. Okay. Goat. Well, the size isn't being set. What if I do less than 0.5? Unless there's still white spaces left by some reason. Vote. Yeah, that's a word. What the shit? Fell next stop. 0 used cruise. Take. Should we allow the words to be cycled? Pearl do golf. Film belt soap. What the shit is this? Xbox? Come on! I guess it was statistically gonna happen. Alright, you know what? No Xbox. God damn, man. Okay. Just gonna, you know what? Let's just edit the one that's here right away. Xbox. Oh, it's the only word too. It's the only 4-letter word. Wait, hold on. Hold on a second. Xeon? Xenon. That's the gas. Okay, yeah. Xeon definition. Scalable processor type. No. Is that just a made-up word? It's a brand. Yeah, it's a brand microprocessor designed. Okay. Either it's from another language or I don't know. Okay. Sure. No Xbox. We'll take Xeon. Xanax. Xerox, Xanax. Two of these are brand names. God damn it. Znet. Zones. Oh my god. Okay. So, what happens when we have a word that doesn't fit? We might have to make it go up to the next word length. Okay. Word length is 4. We are going to use that word here. Okay. Yes. I don't know if that's going to work, honestly, but hope it is. Okay. So while we need to make sure that it keeps increasing the word count number until it reaches one that actually exists. Which we technically could do here. Right? So we choose a letter. If that letter, let's see. Choose a letter. Check if it's not already used. And then check if this letter has words for this length. So we do if we go here in the database, we access the chosen letter. We then use the word length, stringified word length, and then check if the size is above 0. Technically, if there was nothing, it wouldn't be there. Nope, nope, it would have an empty array. And then we populate into it. Okay, that's fine. So, well, actually, would it though? 7 and 10. So it wouldn't even exist. Okay, so we don't check the size. We check if there's a key, is that something we can do? Is that something that has a dedicated function? Has key, yes. So if it has this key, then we allow that letter to be used. Otherwise, it'll just keep looping through it. Okay. That's good. Evil mat onto. Oh, you know what? I know exactly why my movement is messed up. It's because when I transferred the player to align transform to camera, it kept the object at a slight angle. There we go. There we go. 0 ins Dale. Okay. I could do, let's see, when we do shift, we're actually running. Huh. Well, if we're using a modifier key, what key should it be? Shift is very convenient, but we're already using that for sprinting. I could say that if you're moving, and then you hold shift, then you start sprinting, but if first you hold shift and then you start typing the word, then it actually types the word into your combat. Okay. That could potentially work. Right, so if we're standing here, we hold shift, we start typing in Walt. Okay. We start typing in Walt. It will access all of the enemies within combat reach, find the one that uses Walt, and then use the nearest card to deal damage to that enemy. Interesting. Let's see. This might be a little wonky, to be honest, with this kind of a sprint approach. So we have this here, if sprint is pressed and the target direction is not nothing, which means we are actually trying to go somewhere, then running becomes true. So both of these have to be the case. Okay. So we could say and okay, I think I'm stupid. I think attacking spelled 2 T's. Attracking. Yeah. Attacking is false. Then it's going to start sprinting. Okay. Now, running, attacking. Okay, but then we go to, do we have combat? Combat process. If running is false, then if running is false, if input is action pressed, sprint, then attacking is true. And then I guess we can make it active, so we do attacking is false. And that's where we keep this thing. Okay. Now how do we represent that? Well, let's see, we go to the keyboard attack node, and then when the player enters, we'll store it. So we'll go here. Player node is going to be storing the body, and then when it leaves, player node is going to return to null. And then in the process function, visually show attacking mode. So if player node is not null and player node attacking is true, then we need to do something with the modulate of the word. So we might actually want to handle this here. Word modulate target. I'm going to set it to 0.0. If player's not null and player's attacking, then word modulate is going to be 1.0. And then player near has to be also true, which honestly, we don't need player near if we have player node, because player node kind of tells us the player is near. Okay. Near player, there we go. So if this is null, player's not near. So we can do target is 1.0. Might have to break this apart into two stages. So if it's null and if it's attacking, then it's 1.0. If it's not null but it isn't attacking, then what target module is going to be 0.7. And then if the player is null, 0.0. So it disappears entirely. Okay. Maybe we can use caps lock to, oh. Well, it works. It's not strong enough. Say 0.3. Okay. Bricks. Cove. Euro. Okay. Just making sure. eBay? Come on, man. These are not words. Unless they are, and I'm just stupid. Okay. Okay, so we need to do what? What's next? Well, next we need to make it so that when we are matching the word, it damages the enemy. Or at least it starts filling up the word. Okay. So in the player, which technically we don't need to switch to the entire scene. Let's go here. If attacking is true, then anything with type has to be stored. Let's see. Whoops. Var typed combat word. Okay. Input get string. Get last mouse velocity. Is there by any chance an input that just gives us the last typed word or the current typed word? Something that returns a string. Get your name. Because I think either Python has it or some other language has it. Maybe it was Pygame or SDL or something. Get axes, get action strength. Maybe JavaScript has it. Let's see here. Godot get typed string. Typed text. Player input text. Line edit. Line edit. I mean, maybe. So, I guess maybe we put the line edit in focus. This might be janky. Oh, this might be janky. Huh. Hold on. Dot get last typed letter. I don't know about this. It might work, but it stinks of jank. Guess we'll see. So, line edit. We're gonna call it combat command. Okay. This isn't actually going to be visible, but I'm gonna place it here for the time being. Okay. Whoops. Okay. If attacking, we're going to talk to combat command, set focus, focus, grab focus. So it's just going to constantly be grabbing focus. While I guess that might be okay because we are in the middle of pressing attacking. So we're holding shift for this. Okay. There you go. Okay, and I think maybe when we press it, if input is action just pressed, sprint, we are going to clear other things in the game can grab focus, so we got to be careful about that. Okay, so if I'm running, press shift, it doesn't focus it because we started running first. And when we enter here, hold shift. Nice. It does actually clear it, so that's good. We'll need to make sure when we grab the string, it is always grabbed. Yeah, it's always grabbed in lower cases. And yeah, well, there you go. So that seems to be working. We just need to get the data. And what can we do here? Make sure this word is matching. Make sure the player's combat word is matching. So we can do this. If player node is not null, and player node, we're gonna get node combat command. Maybe we want to store that. Var player combat command text node. Set it to null. When the player enters, we're going to populate it. Yes, just so that it's easier. And then when we leave, set it to null. Like that. Okay, and if the player is not null, then the player combat command text node is not null. How do we get the text? Is it just .text? .text. String value of the line edit. Changing text using this property won't emit text changed. Got it. Not relevant. So get text and then to lower. To lower. Beautiful. So that returns a string that has been lowered to lower cases. Okay, so and what about this lowered? Well, whatever this is the player has typed in happens to match or begins to match the chosen word. So we're going to do and chosen word begins with, yep, whatever the player has already typed by this point, even if it's partial. Then, okay, well then we can do this. Var word color. Let's do color white. Okay. Now, if it's matching, if it begins with if it begins with, then we say word color is color orange. Okay, and then we need to make this, we can't really do modulate without revamping this code, because we're already messing around with the modulate alpha value here. But we could do word self modulate, and then we're going to make it transition self modulate lerp. I think lerp is a thing, right? Let's see, control or modulate or a color. Technically, we know that modulate is a color data type. We can blend, we can lerp to the color by this amount. Okay, so lerp to the color that we chose here by 0.1 amount. That should do it. Okay. All right. Got it. Okay. So it's already turning orange, but shouldn't really be turning orange. Why? It's too early to turn orange. Player's not attacking. So if player's not null and player is attacking and the word begins with, but the problem is that in the beginning it doesn't have anything. So we're gonna do Control C and the word that they've typed in so far, size of that word is above 0. So they typed something. Now, is that a thing? Is it size or is it length? It might be length. Length, okay. Cool. Okay, so we're attacking. Pull. Oh. Dang it. P is for reset the level. Alright. Where is P? Reload temp. You know what? Let's get rid of that one. Unless we can reassign it to, I don't know, like F11. Is F11 used for anything? F12, F4, F2, F1, F3. Oh, nope. Not by the looks of it. Okay, cool. Let's try that again. Let's see here. Okay, shift. Glow. Aha. Okay, but we moved. We should not be moving when we're attacking. Okay, sprint. That's only one thing. Target direction. Target direction is based off of the global position of this direction mount, which in its turn is based on these button presses. So if attacking, if not attacking, then we do this. Okay. And maybe we will let them maintain their movement so they can do like drive-bys. That might be kind of fun. Let's see. So, okay, no more of this. It still plays the animation, but that's okay. But we can do this and then start Oh, okay. Good. Geez, we need to fix that as well. Right mouse, left mouse. Inventory, right? Or journal. Journal. So if not attacking and we just pressed it, it goes away. Same thing for the inventory, actually. It's right there. Yeah. If not attacking and press inventory, then we allow it to be opened. Yard. Okay. Okay, that's good. That's good. Except, what's next? Well, if the word matches, it needs to deal damage. Okay, so that is... Where can we handle that? Technically right here. If we just check. If the chosen word is the same as the lowercase typed word, how do we deal damage? Let's see. Dummy enemy has generic enemy script. Okay. It has line of sight. We have a state machine for attacking, returning, on attack timer timeout, draw navigation path, line of sight, take damage is called from within the player. That's the player taking damage. So is this, so is that. That's the enemy taking damage. Okay. Now, enemy hit enemy. We deal damage, play the sound effect, add the sound effect. This is a little dumb. Get tree, current scene, add child, new sound effect. One shot sound effect stem. Yeah, I mean, honestly, we could have just kept that as a part of the player and not worry about it too much. But then check top card window. Consume top card. This is the important bit. This is the important bit. Okay, so let's make a function in the player called attack with card. We're gonna check top card wind up. That's making sure that the card has been wound correctly. And then consume combat card. What the heck does that return? Returns a result. If it is a dictionary, then it does... I suppose that it can also return a false. If attack card was not wound, I guess we can return false here. And then here, what do we return? Let's return true for the time being. So this function is actually going to be called by this node, the keyboard attack node. right? So we do player node. We'll call that function. And then for now, that's all that we really want to do. Oh, it might actually use all the cards now. Hold on a sec. Just for good measure, I'm going to clear the word that the player just typed. So it doesn't continuously do it on the loop. You don't use state for the player? Not for this one. Sorry, didn't notice the message. My bad. Okay. I might. The player might end up being really complex. I might switch to using states. Luck. Okay, use the card. And I guess... Oh boy, look at that. This will have to have a very, very visual presentation to it. Okay. What should we do? We need to make it re-request a new word. So we might just have to do this here. Request new word. Paste this in here. Okay. Now, it's important that we remove the chosen letter before we do this. Remove any previously chosen letters. So if this is not an empty string, we're going to talk to engage letters. Actually, we can do it right here. And we're going to erase the chosen letter. And chosen letter is going to become an empty string. Just in case. Choose a, or let's do keep choosing a word until one is valid. Cool. So once we do this, once we actually do deal damage, we're going to choose a new word. Okay. Zoom. Null. Okay. Cool. But is that valid? It was valid. Oh god. I thought it meant null as in no word found. Well, now it's gonna be screwing with me, eh? Fatal error, 404. Invalid. Undefined. Damn it. Okay. Just mess Xeon acid Carl show for Guam Uto. What is this? IE Ruth Asia NASA News Boys Owen Load Neon and anti self. Oh, that should have caught it. Hits. Quit. Keep. Hair. Lewis. Asen. 0. Yoga. ESPN. Really? Really now. Okay. Perhaps when we choose a new word, we should do this. Text is an empty string. Set the size to 1. Reset text box dimensions so that when it chooses the new word, it resets it for us. I might want to actually set the modulate to nothing as well. Isn't step, cure, wake, idle, just. We don't have any cards left, so that's where we have to pull the cards out. Zinc, note. Okay, now the cards seem to collapse too soon. Technically, when we're in attacking mode, okay. I believe, if I remember correctly, there was a special timer. When that timer runs out, the cards collapse back to a small spot. Thirst timer, hunger timer, gift stuff timer. Gift stuff timer? What free stuff are we giving? In combat card retreat cooldown. Well, that's very specific. Thank you very much for that name. Me from the past. Combat process. So if attacking is true, we will tell this node to start. And we'll just continue starting over and over and over again until we're no longer in combat. Okay. West. Item. USPS. Ide. Mint. Hips. Wire. Zoom. Lock. Done. Okay. Could I, in any way, shape, or form, make the effect of the letters actually being matched and being typed? Let's see. I have an idea of how I might be able to pull that off. We'll have to use a panel container here. Okay, word box. I'm going to take the theme, copy the theme, clear it from here, and then put it into the word box. Not material, theme overrides. Paste. Put the word in, duplicate the word. This is word typed. Okay. I think that should be okay. Let's keep it as word. And then this is word target. And then word typed is inside. So if we say, let's say, arrow, we have a second one called arrow, and then you can see how it just matches the same exact space. So if I make this one be, let's say, orange or red, then we can mess around with, there should be like a reveal index. Text selection, display text. Like that. And then we could just increase it one letter at a time. Okay? Okay. Now, the panel will be reduced. Ready? Whoops. So go back here. Word target. Word typed. And then this is where we reset the size of the box now. Word target. Chosen word. Word. You know, I could just say, nah, let's just do it. Word typed. I was going to say I could write a piece of code that just copies into the word type whatever's in the word target, but that might take a single frame to update, which may show up as a visual glitch. So we'll just do it like this. This is alpha, size. We don't seem to be talking to this anywhere else except here. But that's the word, that's the box. We're okay with coloring this. Actually, that's interesting. We can now color the box and the text separately. Okay. Position. All right, let's see if this works. Let's see how much we've broken. Oh, okay. Sync. Cool. That works. So we just need to make, let's see, as long as it matches. If it's more than 0 and it begins with, so there's partial match at least, var partial typed amount. We're going to get the text, get the length of the text, and then we're going to talk to the word typed, and then visible characters is going to be set to this amount. Okay, now if that does not happen, if it's not the case, the visible characters is 0. Oh, okay, we failed. What does that say? Any day now. There we go. Non-existent function length. Ugh. Yeah, maybe the one who's going to benefit from this typing experience is me. Solo. Ha! Nice. Year. News. Maybe not red. Maybe we can make it orange as well. Color orange. Pick color. I'm just going to copy that color code. And then, there we go. Hours. Bats. East. CNET. Okay. Tray. Okay. All right. So what's next? Well, next, we need to deal the appropriate amount of damage. We currently just make visuals go bloop, bloop, bloop. Let's go to combat process. Combat process? No. Consume combat card. Consume combat card. So we return either false or... Oh. What the What? Consume combat card is the function that consumes the combat card and returns either the duplicate of the data or returns false. Let's make it return an empty dictionary, because that's easier, because we can just simply check if the returned data happens to be empty or if it has something in it. Yeah, like this. If it is dictionary, like we don't need to do this anymore. If it is empty, if not is empty, what do we do? So attack with card does two things. Before consuming the card, it checks if the card has loaded, because there's a cooldown for each card. So what we need to do, I guess in this case, we no longer need to do any of this. We could just say return result. Okay. Now, and then here we also don't need to do is dictionary. This is old combat code, but I'll fix it anyways. If not is empty. There we go. Okay, cool. This is for like our mouse attacks, which maybe we'll keep it if we don't nuke it in the process of developing this new combat system. Maybe we'll give the player the ability to choose what kind of combat system they would like to play. Seems a little excessively ambitious, but whatever. Maybe you don't want to be sitting there typing and learning. Maybe I'll give an achievement shaming them for it. Those who choose the typing mode, they will be like scholar mode. And then those who choose to do the mouse swipe, I'm gonna call it imbecile mode. And that's gonna be the achievement you get. Imbecile achieved. Okay. Anyways. Result. Consume combat card. Return result. So, what does that actually give us? Well, that should give us a dictionary telling us how attack data, right, telling us how much we've just attacked by. Now, if, if attack, let's call it attack card data is empty. We know that it's a dictionary. It just doesn't quite know that it's a dictionary here. If it's not empty, then what? Well, we need to take a look at combat card because it will have the data required. Damage. That's what we need. So damage. Okay. So that's the damage amount, and what do we do with this information? Well, we know that the owner of this whole keyboard attack node is the enemy. So we do get owner. That's the enemy. And we know that the enemy would have a take damage function, which takes the amount by which we damage that enemy. So we go back here, tell it to damage the enemy. Beautiful. And that's going to damage the enemy, and that will handle cycling the card, putting it back in the deck, going to the next card. And maybe using sound effects, we can do something in the lines of audibly communicating to the player. Maybe they typed in the word a little too soon. Maybe, maybe. Yeah. Okay, that's fine. What else did I want to do? I wanted to make it so that when we request the new word, modula.a is going to be set to 0.0 so that we don't see the word be populated instantly. We want it to come in. Okay. So we do this, just, and we crashed. Okay, let's figure it out. Damage. Invalid index damage. Is that really not? Hold on a second. What's in here? Attack card data, card type, image, stats damage. Okay. So, stats damage. Interesting. How did I miss that? Combat card. Stats labels. That wasn't the data. Attack data. My card data. That would be right there. And then it takes the card data from this when we set the card, and there's the stats. Okay. Got it. That's fine. Again, we've looked at the combat system quite a while ago, so don't quite recall what it was. Okay. Tion, Anna, nice. Okay, so it disappears. Char. Oh, that failed. INCL. Was that INCI? Knowledge as a function is empty and base nil. Huh. We called attack with card and it returned nil. Because return. Because we did it too soon. So we're gonna return an empty dictionary if that happens. Okay. Maybe I can build on the system. Maybe give the player the ability to choose which card they would like to damage with. Maybe I can do like 1, 2, 3, 4 on the keyboard while you're in combat mode. That will select which card you want to damage with. But if it's not a front card, you pay the cost of whatever the cost of moving the card is. Right now it's like, what is it, 1? Yeah, so the 2 dashes, that's the cost of moving the card. Except it doesn't seem to want to behave. There we go. Alright. Lux. Oh, okay, that's not good. Lux, Dome. Dome. Sight. Conf. Xeon. Vote. Open. I might actually end up just removing any sort of words, any sort of word entries that only have like 1 word in it. Or maybe establish some sort of a minimum. At least like 10 words. It's going to limit how many words we can have, but at least we're not going to be likely to hit the same words multiple times. Even, jail, neck, on, cast, neon, volt, Iraq, ring, Owen, oh, we've hit that multiple times, quit, Jake, dame, rats. Now, is this going to work if I hide the node? I doubt it. I think it's not going to work because hidden nodes cannot take focus. So we might just have to have that node exist. Okay. Lucy. Nope. Okay, so that doesn't work. All right. Yes. So we need to make it ignore the mouse. Do not take over. Modulate invisible. Maybe we could keep it. It's an extra feature at no cost. The display of what you're typing. Rugs, must, quiz, tape, stud, vids, Xeon, apps, blah, rail, yard, oh, yard, vice, firm, vote, Andy, up, look, edit, item, exit. We could make an effect where that word just kind of lifts up and disappears while the new word appears beneath it. Could that be a fairly cheap effect? Let's see. We're at 1 hour and 28 minutes. We might as well give it a try. Word. I'm gonna duplicate it. Oh, God, no. Don't make scene root. Okay, save branch as scene. That's what I want. This is objects, UI, word, combat, completed. Okay. Word, combat, completed. Let's save, attach a script. Scripts, UI. Okay. So what happens to this? We just want this to fly up. So we're gonna do position on the y-axis, plus equals, let's do 10 times delta. Okay. And then we're going to say modulate alpha minus equals 5 times delta. If modulate alpha is less or equals to 0.01, Q3. QUE free. Okay, that's the idea. We will make a function called setText because we technically have 2 of these that need to be set. Okay. The word typed is gonna have its visibility set to -1, so it's just gonna be fully visible. And then text is gonna be set to txt for both of them. Okay. Cool. So let's go back to, let's see, this. We're going to need to instantiate one of these effects, so we're going to do what? Word combat completed preload is going to contain the preloaded version of this. Then when we go here, we take damage, where the enemy takes damage. We make var new, just new comp. We instantiate a new one. We take the UI, add child of new comp. We will talk to this, set text, so that's a custom function. We are going to set it to chosen word, and then position is going to be set to the position of this one. Yes, and we don't need this one because the sole purpose of it was to just copy it and paste it. Okay. Let's see. Real. And, oh, did we crash? Nope. Okay, it's working. It's very fast, but it's working. Let's see. So first of all, has to be going up, which is in 2D space is going negative. Next, we're gonna make it reduce and modulate quite slower. I think even that's not gonna be fast enough. JPEG. Okay, yeah, that's way too slow. Let's do like 80. Bugs, Slim, Need, York, Lord, Myth. Oh. Interesting. Oh, we don't have any cards. Right. Yeah, we need to make sure we cannot grab the cards while they're in the middle of flying up. Term, town. Okay. Nice. That dude's dead. I don't think we have to worry about the damage text disappearing when we kill off the character. That's fine. Gray. Sion. Owen. Dirt. Char. Void. Oh, don't have any characters. We may want to have a button. Like, what? When we do shift, maybe tab to pull a card out. Pull card. Tab. There we go. No. Tab, I say. Dang it. There we go. Okay. Do we have a pull card function? If player near attackable enemies, pull cards out. No, that's not what I need. And don't even have it focused on cards. Bottom right. What the shit, man. There we go. Card retreat cooldown. So we might be using it if it's stopped. Yeah, but that has nothing to do with the card itself. Interesting. Hold on a sec. We didn't program the combat deck by itself. Okay. Build attack deck. Add attack deck card, card data. Add a single card to the attack deck. Okay. I think that might be it. Back to deck card data. Uh-huh. Attack data. This is for putting the card into the deck. Send the card data to whatever was just attacked. Consume combat card. Combat card hand. So this has to involve that node if we're putting a card into it. Add hand card. But it wants the card data. So grab a new card from... Hey, look at that. Perfect. We have a function for this. Nice. We don't have to code our own. Combat. Combat process. Okay. If attacking, if pull or input that is action just pressed, pull card. Come on. Oh, you suck at stuff. Pull card is pressed. We're going to call this function. Now, does this function do the checks and everything? Attack deck size. If it's above 0. Not really. It's two places where we use it. That's one of them. Grab new. Where do we use this? It's a different script. Player and play. Oh yeah. Deck card blank. Grab new card from deck. But where do we pay the... Oh, there it is. Card action AP penalty. And if the result is there, which curious that it turns it like this, but okay. Let's go over here. Okay, which is really right here. Paste this code in. Player node, we are in the player nodes. And then we can also check the stats. Deck takeout stats. Okay. This has to come from somewhere. So we have to focus on that. We don't queue free anything. We don't click anything. We just run grab new card deck. But we need to know deck takeout AP cost. That is that the player stat? That is the player stat. So this is universal. How much it takes to take out a card out of the deck. Okay. Grid. Nice. Okay. Stat. Ism. NATO. Oh boy. Let's get a little political here, Bellis. Duke, Nukem, Fish, Yale. Nice. And then we can do... press a button. Okay. Nice. That's perfect. So... and then we leave. Enter again. Jews and spam. Oh no. Okay, let's not have Jews in our word. It's not a swear word, but you know, if we hold on. Islam. Oh yes. Yes, let's get this out of here as well. Indie. Nice. Iraqi. Yeah, no, out of there. Oh god, what am I gonna have to use AI to go through this? Irish, Italy, India, issues, index items. Yeah, I'm sure. Oh, hold on. I saw something. Oh. All right. Yeah. I don't know, man. So many words. Maybe I'll do I'll just like ask ChatGPT or something to give me like an array of 500 words in the organized fashion. It might give me duplicates, but at least we can give it like instructions to avoid like country names, brand names, swear words, curse words, body parts, stuff like that, right? Or, you know, like sexual organs. Jack. Trek. Hello. Twice. York. Boat. Miscellaneous. Wars. Oh, jeez. Says. Pawn. Grab. Pike. Bass. Over. Zoom. Is it me? Oh yeah, we're not dealing damage right now. Quit. Again, some sort of an auditory cue might be appropriate here. Quad. Hide. Nice. Alright. Now, do we want that to be above the enemy or below the enemy? Enemy could be of any height, but technically they're always going to be touching the ground, so that's kind of a common vector. Okay. Oops. Ammo. A lot. Epic. Sword. Worm. Rent. Baby. Alright. There we go. These guys don't really do any damage to me, but... guys. Wait. Hold on. Hold it. Gaze. You are out of here. Bye-bye. Okay. Wait. Trance. You're also out of here. Alright. Weird. No? If I know how to spell that. Alright, we'll look it up. Alright. Good. Man, we're gonna have to do a lot of filtering. Cool. So, that's it. We have the combat system in place. We have... I mean, that's actually pretty good. It's not guaranteed, that this is gonna be the combat system we'll go with. It works. The only thing that's really left to do is have it dynamically select which words to use, or the length of the words to use. But for the most part, yeah, for the most part, that's what I need. If I come up with something else, then well, the interesting thing, if I come up with a different combat system, I'll likely just make it as a different module, just like what I did here. It's just a separate node. If I don't like the system, just delete this node, and that's it. That combat system is gone. At least the enemy side of it. I honestly don't know what other combat systems to use. If I want to lean in more on the whole card thing, then I might want to take a look at, I don't know what, like dragging the cards onto the enemy of choice, right? Maybe borrow some other card systems, like having a deck, or having, the, what is it, the floor. What's the technical term when you're playing a deck of cards with like Magic the Gathering or something, and then you put the card down? The field, is it? Whatever the heck the name is. Yeah, have the player like drag those cards in. Again, we're not leaning too hard into the whole card system, because leaning too far into the card system means that we are probably going to be doing turn-based combat. We don't really want to do that, so we gotta work something like this. By the way, this health bar, I technically could do that as a material, because right now it's a little janky. It uses a, whatchamacallit, it uses two 3D sprites, and then sometimes they kind of have a little bit of Z fighting. Oh, am I using two 3D sprites? HP bar. No, it's just, oh no, it's just a really long animated version of it. Oh god. Yeah, this is before I was a little bit more skilled with shaders and stuff. Oh well, okay. It is what it is, fellas. It is what it is. Well, with the combat system done and out of the way, we can move on to something else. And then if my mind conjures up a different combat system, then we can just, implement that and see how that works. But for now, I'm gonna stop this here. I need to take a bit of a break. I don't know if I'm gonna be back. It's already 12, so I guess we'll see. We did a little bit of work, and what work we did, I think, is useful. Okay, that's it. Thanks, fellas. Appreciate the company.